Hello calculus students, and welcome to the continuing series of videos on finding exact area or computing the exact value of a definite integral. And we've done some random stuff, some review, and now we get to the real deal of the day, which is how do we evaluate the exact answer. And the goal is to start out with an estimate, then improve our approach to get a better estimate, and then finally culminate in an exact answer. So I'm going to start you off here on what looks like a busy work problem, where you're just computing the areas of rectangle. But let's just pay attention to the notation that I'm using here, because that's going to help us to extend the concept to something more important and more useful. So we're going to use 5 rectangles of equal size, and I'm going to use the right side. Okay. It doesn't really matter which ones you use, but using the right rectangles is going to make things a little bit easier on us. So I'm going to go ahead and do that. Okay. So I've marked off here my graph, and then we're going to draw in some rectangles, and then we're going to figure this out. Okay. So I'm going to start out the first rectangle is the rightmost one, which is the one all the way up to 7. The second one, so I want to go from 6 up to the curve, and then make a rectangle there. And then just repeat this process until I get all the way down to 2. Okay. And by doing so, I should have exactly 5 rectangles. They're supposed to be equal sized. I didn't do a very good job here, but hopefully they're not too far off from the actual answers. Okay. So we're going to slice up this way. So in this case, we're talking about the right approximation using 5 rectangles, so R of 5. And each one of these rectangles has a width of 1. And then their height just depends on where you're at, but you have the first height here is f of 3 plus f of 4 plus f of 5 plus f of 6 plus f of 7. Okay. Now we're not going to compute this because I'm not actually interested in the computation of the estimate. We've done this already. I know all of you can do this. But what we're interested in is generalizing this idea. So I'm going to write this in a way that seems overly convoluted, but I promise you will lead to something useful. So I'm going to write this as this 1 here as 7 minus 2 over 5. And this, let's think about where this is coming from. 7 is the right endpoint, 2 is the left endpoint, and we're just taking the length of this segment and we're dividing it by the number of rectangles, and that is in fact 1. And instead of writing f of 3, I'm going to write this as f of 2 times 2 plus 1 times 1. Okay. I know this is very ridiculous and strange to you, but I'll explain to you why I do this. Okay. So f of 4, I'm going to say this is f of 2 plus 1 times 2. Okay. And I'm just going to repeat this. F of 5, that's f of 2 plus 1 times 3. F of 6 is really f of 2 plus 1 times 4 plus f of 7 is 2 plus 1 times 5. Now, the reason I did this is so that I can rewrite this in some way as a summation. This 2 here is fixed. This 2 at the start of each of this never changes. This is the left endpoint. Okay, that's where that 2 comes from. These 1s in here, let me just highlight these 1s right here. These 1s are all the same. Okay. And the ones that I highlighted, that is the width of each rectangle. The ones that I highlighted is, so 1 in this case is the width of each rectangle. Okay. So do some color coding here. And then finally, what the parts that are left, 1, 2, 3, 4, 5, those values are our iterators. Okay. So I don't know if you can see this here. 1, 2, 3, 4, and 5, those are our iterator. And so the way I think about this is the R of 5 here is essentially equal to 7 minus 2 over 5 times the summation of I equals 1 to 5 of f of 2. These are the left endpoints, and they never change, plus the width of each rectangle, which happens to be 1, times the iterator. This is important. The iterator in this case is I. Okay. So if you notice, this is kind of weird. I haven't actually calculated the basic the actual numerical value, because I'm not really concerned with that right now. I'm more concerned about taking this idea, this very simple case, and understanding each part of it and being able to write this as a summation. Okay. So I'm going to end this video here, and then I'm going to start another one where we get into an extension on this. We're going to go and calculate the result of 5,000 rectangles. Okay. Thank you for watching. Have a wonderful day, and remember to check out the next video.